We continue this morning with our series, Pushing the Limits. Groundbreaking work is being done at Duke University. You know about computer networks linked together? How about brains? Scientists say it is already happening. The research could revolutionize medicine by healing people with severe disabilities. Jeff Glor went inside the lab, attempting what others called impossible. Jeff, good morning.
Charlie, good morning to you. It sounds like science fiction, bringing minds together, actually pooling brain power to make a kind of super brain. Seems hard to believe until you see it up close. Meet Mango the monkey and his problem-solving partner, Romeo. Inside this lab at Duke University, both primates are currently separated physically, but will soon be connected mentally. Signals from their brains will be merged, the result of years of research inside the lab of Dr. Miguel Nicolelis.
I first dreamed about this many years ago.
Dr. Nicolelis has made studying the brain his life's mission. It was his neurological work with rats that first gained widespread attention. Then he taught primates how to move wheelchairs and exoskeletons using only their minds. That was followed by his wildest idea yet, trying to merge the power of multiple brains.
We needed to create a new paradigm, and it was when we introduced this concept of linking brains to machines.
Has anybody ever said to you, you can't do this, it's impossible?
Oh yes. We got back reviews from our colleagues, some of our colleagues saying that we needed some help, like the psychiatric variety.
They said you're not doing work on other people's brains, you need work on your own.
Yes, they basically recommended that I create a brain-machine interface for myself, yes.
Well, one word that comes to mind is mad. Right, mad scientist.
Dr. John Sampson is the chair of neurosurgery at Duke.
What he does is seemingly crazy until you talk with him and you think about it enough, and you suddenly understand that he just has a very deep understanding of not just how the brain works, but of how the whole nervous system works.
This is what Dr. Nicolelis and his colleagues came up with. They put ultra-thin, flexible metal filaments into the brain tissue.
But these are the real pieces of magic.
It's almost like little whiskers inside the brain.
Exactly. They're the diameter of a hair, and we can put them in different lengths, so we record a volume of brain tissue.
The filaments pick up the electrical activity of living brain cells, hundreds if not thousands, which are communicated to a computer, and then, as we watched, merged together. Their combined brain signals are moving these avatar hands to touch the targets. So we're looking at what seems to be one body there, but it's actually two brains.
Yes.
What do you call this?
I call this a Brainet.
Brainet.
So we are connecting multiple brains to achieve a common goal.
We see this in nature a lot. Flocks of birds, a herd of cattle, a school of fish.
Yes.
That's in nature. Is this essentially what you're recreating in a lab?
Yeah, to some degree, yes. We wanted to understand how these animals are capable of working together and generate these group behaviors, these social interactions.
Are the monkeys hurt?
No, not at all. They live many, many years with this, and they're very playful because they're doing some things that no primate ever thought they could do.
Dr. Nicolelis says the implications are enormous. If the brain signals of primates can help other primates in a controlled environment, could a healthy human brain help heal a damaged human brain? The goal eventually is to potentially help somebody who is paralyzed walk again.
Yes, this is. We start with spinal cord injury, but we are hopeful that this could be used for other disorders, neurological disorders like strokes, and even in some cases Parkinson's disease.
Work he's already put to the test. Last year, Dr. Nicolelis and a team paired the mind of a 29-year-old paraplegic to a robotic skeleton. By simply thinking about it, Juliana Pinto delivered the World Cup opening kick.
He actually felt the impact, and he had the clear sensation that he actually kicked the ball. It's important that the patients feel the ground, feel that they are doing that by themselves, and have a sensation that is realistic.
I think the potential that Dr. Nicolelis is bringing to the field is the understanding that we are not limited in our minds. Our bodies are what's limiting us. There really are almost no limits to what a single human brain could do or what several brains could do together.
We are just starting to realize how complex it is, how 100 billion neurons interact to create what we call a human condition. This is the big challenge.
100 billion neurons is what we have in our brain?
100 billion neurons. That's exactly what we have in our brains, Charlie. Yeah. So Dr. Nicolelis has done this with 3 brains already, working together. He hopes to include many, many more. The hope is in the very near future, this BrainNet research can help disabled human patients. That's a lot of neurons, isn't it?
It is indeed, but it just seems like it's so unlimited in which the possibilities are.
And you talk about that many neurons. We're only talking about right now tapping into hundreds or thousands of them. Imagine what could be next.
I wonder, does everybody have 100 billion neurons? 'Cause I've seen a couple people, I'm thinking,
You have
I'm missing
more.
a couple.
You have more.
Not naming any names, but it is fascinating. It is fascinating what you're doing.
But
What he's doing.
but their names are.
That is awesome. That is awesome.
I won't do that.
We kind of
Y'all know who I mean, but thank you, Joe.
We know.
Thank you very much.
We kind of have a mind meld going on in the morning.
That's
don't we?
right.
Yeah.
We do, Nora.
The CTM Superbrain.
Tomorrow, our series, Pushing the Limits, takes you for a loop. Learn how the Hyperloop could help people and cargo zoom through a tube at near supersonic speed. Go behind